Hi, my name is Elgin. I'm a solutions architect here at Amazon Web Services, and we are so glad to have you joining us today at the AWS Summit Online. This particular session, using Amazon SageMaker to accelerate your machine learning journey, is intended to provide an overview of new features that you can use to make your machine learning on AWS easier and faster. We see the machine learning stack having three key layers. In the bottom layer are the frameworks and infrastructure for those comfortable building and maintaining their own machine learning platform and underlying infrastructure. In the middle layer are the machine learning services that make it easy for machine learning developers and data scientists to build, train, and deploy machine learning models in a single click with Amazon SageMaker. In addition to the IDE, all Amazon SageMaker features are available through APIs. In the top layer are the AI services that allow all developers to use pre-trained and auto-trained models to add intelligence to any application without machine learning expertise. Today, we are going to focus on the middle layer. It's incredible how many customers have started using Amazon SageMaker. Customers all over the world have used machine learning on AWS to solve real business problems with machine learning. For example, Grammarly uses SageMaker to develop their TensorFlow models in a distributed environment, helping millions of people communicate more effectively by offering writing assistance through a combination of natural language processing and advanced machine learning technologies. From manufacturing companies like Panasonic and Siemens, to car sales companies like Edmunds, and financial services like the Dow Jones, Amazon SageMaker is being used across a multitude of industry sectors. Customers choose Amazon SageMaker for a variety of reasons. Firstly, SageMaker helps reduce the cost of machine learning through a few key features. Data labeling can be expensive and highly dependent on human labelers for accuracy. Amazon SageMaker Ground Truth helps you get to that ground truth for training data automatically, with accuracy and at scale, with 70% reduction in labeling costs. In machine learning, elasticity is really important. The resource requirements of models are hard to determine upfront and can change as models are trained with new data and updated algorithms. This means that getting the right balance of resources and costs often relies on guesswork or intuition and can be quickly out of date. Amazon Elastic Inference helps you provision just the right amount of GPU resources you need for your machine learning workloads. You can reduce the cost of training your machine learning models by up to 90% using managed spot training. Managed spot training uses Amazon EC2 spot instances, which is spare EC2 capacity, so that your training jobs run at much lower costs compared to Amazon EC2 on-demand instances. Amazon SageMaker manages training jobs, so they are run as and when compute capacity becomes available. As a result, you don't have to poll continuously for capacity, and managed spot training eliminates the need to build additional tooling to manage interruptions. Managed spot training works with automatic model tuning, the built-in algorithms and frameworks that come with Amazon SageMaker, and custom algorithms. Amazon SageMaker lowers the total cost of ownership over a 3-year period by at least 54% compared to other cloud-based machine learning options, such as self-managed Amazon EC2 and AWS-managed Amazon EKS. The analysis holds true for small teams of 5 data scientists and extra-large teams with 250 data scientists. In addition to lowering the total cost of ownership, Amazon SageMaker's productivity features enable you to put machine learning ideas into production faster and improve data scientist productivity by up to 10 times. Amazon SageMaker promotes ease of use without compromising on security. You get end-to-end encryption, private network connectivity, authorization, logging, auditability, security requirement enforcement, and notebook lifecycle configuration. At the same time, you can access all the components needed to build, train, and deploy machine learning models through the world's first integrated development environment for machine learning, Amazon SageMaker Studio. Amazon SageMaker really does take the complexity out of machine learning. Developers can develop and deploy models with just one click in the SageMaker console and train once, run anywhere from the cloud to the edge. For customers that prefer to manage their containerized applications using Kubernetes, Amazon SageMaker is investing in delivering the best experience for machine learning on Kubernetes by creating Kubernetes operators and Kubeflow pipeline components for SageMaker services. Kubernetes users will be able to use managed machine learning services for training, model tuning, and inference without leaving their Kubernetes environments and pipelines and without needing to learn SageMaker APIs. Customers can create hybrid pipelines with SageMaker pipeline components for Kubeflow that can seamlessly execute jobs on AWS, on-premise resources, and other cloud providers. In machine learning, using the GPU's advantage in memory bandwidth and parallel architecture can be beneficial. However, keeping a GPU instance on for extended periods of time can be costly. Customers can lower training costs by not paying for idle GPU instances. With SageMaker operators and pipeline components for training and model tuning, GPU resources are fully managed by SageMaker and only utilized for the duration of a job. Customers with 30% or higher idle GPU resources on their local self-managed resources for training would see a reduction in total costs by using SageMaker operators and pipeline components. Traditional machine learning development is a complex, expensive, iterative process, made even harder because there are no integrated tools for the entire machine learning workflow. You need to stitch together tools and workflows, which is time-consuming and error-prone. First, developers need to select which algorithm or framework they'll use to build the model. Then, they need to train the model on how to make predictions and tune it so that it delivers the best possible predictions. Finally, they need to integrate the model with their application and deploy this application on infrastructure that will scale. Many of the tools developers take for granted when building traditional software, like debuggers, project management, collaboration, and so forth, are disconnected for machine learning. For example, while notebooks are great for an individual developer to build models, it is hard to share work with peers. Another example is model tuning, which can take days or even weeks of tedious work. Typically, to tune a model, you start with something random and iterate through adjustments to see how they change the model. It can be a very long cycle and require adjusting thousands of different combinations. In response to these challenges, AWS has regularly added new capabilities to Amazon SageMaker since launch, with more than 50 new capabilities delivered over the past 12 months. These capabilities have helped many more developers build custom machine learning models. By bringing tools together through an integrated development environment, you can test, debug, deploy, monitor, and profile all within a single environment. You, as a machine learning practitioner, have the flexibility to use automated machine learning or use any component as a modular capability. The first feature I would like to introduce is Amazon SageMaker Studio, a visual integrated development environment for the complete machine learning workflow. SageMaker Studio unifies all the tools for machine learning development. Developers can write code, track experiments, visualize data, and perform debugging and monitoring all within a single integrated visual interface, which significantly boosts developer productivity. In addition, since all these steps of the machine learning workflow are tracked within the environment, developers can quickly move back and forth between steps and also clone, tweak, and replay them. This gives developers the ability to make changes quickly, observe outcomes, and iterate faster, reducing the time to market for high-quality machine learning solutions. Here is what Amazon SageMaker Studio looks like. In this example, we are making updates to models inside a notebook and immediately seeing how changes impact model quality using a side-by-side view of your notebook and training experiments. SageMaker Studio is available today in the US East Ohio region, with support for more regions to come. We invite you to give it a try yourself. The next feature we'd like to talk about is Amazon SageMaker Autopilot. This feature allows you to build classification and regression models without deep machine learning knowledge. Just provide a tabular dataset and select the target column to predict, and SageMaker Autopilot automatically explores machine learning solutions with different combinations of data preprocessors, algorithms, and algorithm parameter settings to find the best model. Instead of requiring you to decide which algorithm to use, Amazon SageMaker Autopilot automatically selects the right algorithm from a list of high-performing algorithms it natively supports and evaluates all of them. SageMaker Autopilot also automatically tries different parameter settings of those algorithms to get the best model quality. As a result, you can create a model with a single click. You can now directly deploy the best model to production with just one click, or iterate to trade off metrics like accuracy, latency, model size, and so on. There is no need to worry about data cleaning and preprocessing, since SageMaker Autopilot automatically applies different types of data preprocessors on the data before passing it through to the algorithms to train models. Here is what Amazon SageMaker Autopilot looks like. You can automatically create machine learning models and pick the one that best suits your use case. In this example, we review the leaderboard to see how each option performs, and you can pick the model that best meets your model accuracy and latency requirements. The next feature pertains to the preparation phase of machine learning. Successful machine learning models are built on the shoulders of large volumes of high-quality training data. But the process to create the training data necessary to build these models is often expensive, complicated, and time-consuming. Amazon SageMaker Ground Truth helps you build and manage highly accurate training datasets quickly. Ground Truth offers easy access to labelers through Amazon Mechanical Turk and provides them with pre-built workflows and interfaces for common labeling tasks. You can also use your own labelers or use vendors recommended by Amazon through AWS Marketplace. Additionally, Ground Truth continuously learns from labels done by humans to make high-quality, automatic annotations to significantly lower labeling costs. Amazon SageMaker Ground Truth significantly reduces the time and effort required to create datasets for training to reduce costs. These savings are achieved by using machine learning to automatically label data. The model is able to get progressively better over time by continuously learning from labels created by human labelers. When the labeling model has high confidence in its results, it will automatically apply its labels to the raw data. Where the labeling model has lower confidence in its results, it will pass the data to humans to do the labeling. The human-generated labels are provided back to the labeling model for it to learn from and improve. Over time, SageMaker Ground Truth can label more and more data automatically and substantially speed up the creation of training datasets. Next, let's address data processing. Data processing tasks such as feature engineering, data validation, model evaluation, and model interpretation are essential steps performed by engineers and data scientists in this machine learning workflow. With the new Amazon SageMaker Processing Job feature customers can leverage a simplified, managed experience to run their data processing workloads on the SageMaker platform or by using the Amazon SageMaker APIs. Being a fully managed service, Amazon SageMaker Processing provides a managed infrastructure for distributed processing and model evaluation workloads. Amazon Simple Storage Service is used for inputs and outputs to run your custom script on Amazon SageMaker, with the output in S3. You can bring your own Python script for feature engineering, data validation, model evaluation, or model interpretation. Customers can also choose to use a SageMaker optimized container for popular data processing or model evaluation frameworks starting with scikit-learn. Other frameworks such as Spark, Dask, and Lime will follow soon. With a pay-as-you-go model, infrastructure is created on demand, configured, and terminated automatically after the job completes, so that customers only pay for what they use. Lastly, all of the same security constructs like authentication, authorization, VPC, and network isolation that you are used to working with are used with a consistent set of Amazon SageMaker APIs. We shall now focus on new features in SageMaker that help customers in the build phase of the machine learning workflow. Feedback from our customers has led us to create a new experience for SageMaker notebooks as part of SageMaker Studio. Customers have told us that managing compute instances to view, run, or share a notebook is tedious. Now available in preview, Amazon SageMaker notebooks provide one-click Jupyter notebooks that you can start working with in seconds. The underlying compute resources are fully elastic so that you can easily dial up or down the available resources, and the changes take place automatically in the background without interrupting your work. Amazon SageMaker also enables one-click sharing of notebooks. All code dependencies are automatically captured so that you can easily collaborate with others. They'll get the exact same notebook saved in the same place. This will allow you to build your machine learning features faster while promoting collaboration amongst your team. Here's what SageMaker Notebooks looks like. With SageMaker Notebooks, you can easily generate a shareable link without manually tracking dependencies to reproduce the notebook code. When creating a shareable snapshot, you don't need to worry about dependencies getting lost. All code dependencies are automatically captured, and your colleagues get the same exact notebook each time they access the link. The new Amazon SageMaker Notebook experience is available in preview as part of Amazon SageMaker Studio. We encourage you to try it out yourself. Amazon SageMaker comes with dozens of pre-built algorithms. SageMaker provides high-performance, scalable machine learning algorithms optimized for speed, scale, and accuracy that can provide training on petabyte-scale datasets. You can choose from supervised algorithms where the correct answers are known during training, and you can instruct the model where it made mistakes. SageMaker includes supervised algorithms such as XGBoost and linear logistic regression or classification to address recommendation and time series prediction problems. Amazon SageMaker also includes support for unsupervised learning, where the algorithms must discover the correct answers on their own, such as k-means clustering and principal component analysis or PCA, to solve problems like identifying customer groupings based on purchasing behavior. We will now look at features in Amazon SageMaker that you can use during the training and tuning phase. Training models is easy with Amazon SageMaker. When you're ready to train in Amazon SageMaker, simply specify the location of your data in Amazon S3 and indicate the type and quantity of SageMaker machine learning instances you need, and get started with a single click. Amazon SageMaker sets up a distributed compute cluster, performs the training, and outputs the result to Amazon S3 and tears down the cluster when complete. When you specify the location of your data in Amazon S3, Amazon SageMaker will take your algorithm and run it on a training cluster isolated within its own software-defined network, configured to your needs. When you choose the instance type, including Amazon EC2's P3DN, the most powerful GPU-based instance in the cloud, Amazon SageMaker will create your cluster in an auto-scaling group. SageMaker will also attach EBS volumes to each node, set up the data pipelines, and start training with your TensorFlow, MXNet, PyTorch, Chainer, or your framework script, built-in or custom algorithm. Once finished, the results are stored in S3 and the cluster is automatically torn down. To make it easy to conduct training at scale, we've optimized how training data streams from Amazon S3. Through the API, you can specify if you like all the data to be sent to each node in the cluster, or if you like Amazon SageMaker to manage the distribution of data across the nodes, depending on the needs of your algorithm. Combined with the built-in algorithms, the scalability of training that's possible with Amazon SageMaker can dramatically reduce the time and cost of training runs. Amazon SageMaker can automatically tune your model by adjusting thousands of different combinations of algorithm parameters to arrive at the most accurate predictions the model is capable of producing. When you're tuning your model to be more accurate, you have two big levers to pull. Modifying the data inputs you provide the model, for example, taking the log of a number, and adjusting the parameters that define model behavior. These are called hyperparameters, and finding the right values can be difficult. Typically, you start with something random and iterate through adjustments as you begin to see what effect the changes have. It can be a long cycle depending on how many hyperparameters your model has. Amazon SageMaker makes this easy by offering automatic model tuning as an option during training. Automatic model tuning uses machine learning to quickly tune your model to be as accurate as possible. This capability lets you skip the tedious trial and error process of manually adjusting hyperparameters. Instead, automatic model tuning performs hyperparameter optimization over multiple training runs by discovering interesting features in your data and learning how these features interact to affect accuracy. You save days or even weeks of time spent maximizing the quality of your trained model. You simply specify the number of training jobs through the API or console, and SageMaker handles the rest by using machine learning to tune your model. It works by learning what effects different types of data have on a model and applying that knowledge across many copies of the model to quickly seek out the best possible outcome. As a developer or data scientist, this means that you really only need to be concerned with the adjustments you want to make to the data you feed the model, which greatly reduces the number of things to worry about during training. Machine learning is a highly iterative process. During the course of a single project, data scientists and machine learning engineers routinely train thousands of different models in search of maximum accuracy. Indeed, the number of combinations for algorithms, datasets, and training parameters is infinite. It can certainly feel like looking for a needle in a haystack. We have talked about features like automatic model tuning and autopilot to help machine learning practitioners explore a large number of combinations automatically and quickly zoom in on high-performance models. However, these features can also add to the number of training jobs that are part of a machine learning process. Over time, a new challenge emerges as it becomes near impossible to efficiently deal with hundreds of thousands of jobs. Keeping track of metrics, grouping jobs by experiment, comparing jobs in the same experiment or across experiments, and querying past jobs. Introducing Amazon SageMaker Experiments. In response to your feedback, the goal of SageMaker Experiments is to make it as simple as possible to create experiments, populate them with trials, and run analytics across trials and experiments. Amazon SageMaker Experiments lets you launch, track, compare, and evaluate thousands of model training experiments and model versions to quickly identify best performing models. It automatically manages all the experiments performed by a developer. All machine learning artifacts, including datasets, algorithms, parameters, model metrics, are automatically tracked and recorded. In addition, the system automatically organizes, ranks, and sorts experiments based on chosen metrics, and produces data visualizations to quickly compare and identify the best performing models. Here's what Amazon SageMaker Experiments looks like. You can track thousands of training experiments to understand the accuracy of your model. For example, view here a chart of how different time series datasets impact model accuracy. The service is available today in all commercial AWS regions where Amazon SageMaker is available, and we invite you to give it a try today. I believe most of you would agree with me that the machine learning process can be one of trial and error. A machine learning practitioner needs to contend with software bugs in machine learning libraries, inappropriate initialization of parameters, a poor combination of hyperparameters, the design issue in your own code, or any combination of network and data issues. These issues are rarely visible immediately. They grow over time, slowly but surely ruining your training process and yielding low accuracy models. A feature that we recently introduced to help customers through this is the Amazon SageMaker Debugger. SageMaker Debugger provides full visibility into the training process by automating the process of capture and analysis of data from training runs. Inspection is easy with the ability to analyze the debug data, and also by providing visual indicators about potential anomalies in the training process in SageMaker Studio. It also automatically detects and alerts developers to commonly occurring errors, such as gradient values getting too large or too small. You can also use the SDK to automatically detect new classes of model-specific errors or interactively analyze training runs in a SageMaker notebook. As a result, Amazon SageMaker Debugger reduces the debugging effort for machine learning models from days to minutes by providing complete insights into the debugging process. Another important point is that data collected by Amazon SageMaker Debugger remains in your account, enabling its use for the most privacy-sensitive applications. Here is what Amazon SageMaker Debugger looks like. When training a neural network, the training will cease if gradients are determined to be vanishing. SageMaker Debugger identifies vanishing gradients so that you can remediate before training is impacted. In your existing training code for TensorFlow, Keras, Apache MXNet, PyTorch, and XGBoost, you can use the new SageMaker Debugger SDK to save internal model state at periodic intervals in Amazon S3. The combination of state values, called tensors, are configured and saved during training. Next, you define rules. A rule is a piece of Python code that analyzes tensors for the model in training, looking for specific unwanted conditions. Predefined rules are available for common problems, such as exploding or vanishing tensors, parameters reaching none or zero values, exploding or vanishing gradients, loss not changing, and more. Of course, you can also write your own rules. Once the SageMaker estimator is configured, you can launch the training job. Immediately, it fires up a debug job for each rule that you've configured, and they start inspecting available tensors. If a debug job detects a problem, it stops and logs additional information. A CloudWatch event is also sent should you want to trigger additional automated steps. Amazon SageMaker Debugger is available today in all commercial regions where Amazon SageMaker is available. Lastly, let's focus on the features of Amazon SageMaker that can help us in the deployment and management of our machine learning models. Amazon SageMaker makes it easy to deploy your trained model into production with a single click, so that you can start generating predictions for real-time or batch data. You can one-click deploy your model onto auto-scaling Amazon machine learning instances across multiple availability zones for high redundancy. Just specify the type of instance and the maximum and minimum number desired, and Amazon SageMaker takes care of the rest. Amazon SageMaker will launch the instances, deploy your model, and set up the secure HTTPS endpoint for your application. Your application simply needs to include an API call to this endpoint to achieve low latency, high throughput inference. This architecture allows you to integrate new models into your application in minutes, because model changes no longer require application code changes. A feature that we introduced recently is Amazon SageMaker Model Monitor. This feature tracks models in production and detects errors so that you can take remedial actions. It eliminates the need to build any tooling to monitor models in production and detect when corrective actions need to be taken. SageMaker Model Monitor analyzes the data collected based on built-in rules or customer-provided rules at a regular frequency to determine if there are any rule violations. The built-in statistical rules can be used to analyze tabular data and detect common issues such as outliers in prediction data, drift in data distributions compared to training datasets, and changes in prediction accuracy based on observations from the real world. With Model Monitor, you can get alerts in the Amazon SageMaker Studio interface when rules are violated, and metrics are emitted in CloudWatch so that you can set up alarms to audit and retrain models. Here is what Amazon SageMaker Model Monitor looks like. In this example, view charts with important model features and summary statistics, watch them over time, and compare them with the features used in training. Some features drift when the model is running in production, which can indicate the need to retrain your model. You can use Amazon SageMaker Model Monitor today in all commercial regions where Amazon SageMaker is available. This capability is also integrated in Amazon SageMaker Studio, our workbench for machine learning projects. In summary, here are new features that we have recently released for Amazon SageMaker that can streamline, simplify, and accelerate your machine learning. We've looked at the new experience that SageMaker Studio and SageMaker Notebooks provides, incorporating the features of SageMaker Experiments, Debugger, and Model Monitor. We've also looked at how SageMaker Autopilot, Ground Truth, and Processing jobs can help in the data preparation phase of your machine learning workflow, as well as how SageMaker operators for Kubernetes can simplify training, model tuning, and inference for Kubernetes users. Thank you for your attention. We look forward to hearing your feedback as you try these new Amazon SageMaker features and how they helped you in your machine learning journey.